Welcome to The Explainer. Today, we are diving into a really fascinating research story about teaching AI teams how to remember. It's a story of a brilliant discovery, a shocking realization that it might all be wrong, and a super rigorous plan for a do-over. And it all kicks off with one single perplexing sentence. Okay, let's just process this for a second. We gave agents half an answer and they got worse, not better. I mean, how is that even possible? How can giving an AI more information actually lead to a worse outcome? Well, this paradox is the central mystery a team of researchers stumbled upon, and we're about to unravel exactly what they found. So, the researchers started with a pretty common problem. They had this team of 8 specialized AI agents, one for infrastructure, one for marketing, the whole deal. Each one was brilliant on its own, but as a team, they had total amnesia. The marketing agent had absolutely no clue what the infrastructure agent decided yesterday. Every single session was a cold start, totally from scratch. Their first solution was just elegantly simple. No fancy databases, no complex vector stores. Nope. Just structured text files. Think of it like a digital filing cabinet for meeting notes, big decisions, and lessons learned. They called it poor man's memory, or PMM. The idea was to mimic a human team's institutional memory, giving the AIs this shared history they can always look back on. And, well, it worked. Maybe a little too well. Their first big discovery was a real shocker. When they put the system to the test, they found that a whopping 83% of the memory's benefit came from the agents actively going and finding the information for themselves in those files. Only a tiny 17% came from the info they preloaded into the AI's immediate context window. So this was a huge insight. It's way better to build a well-organized library that the AI can search through rather than just trying to stuff its head with a bunch of facts before it gets to work. That ability to go and find information on its own, that was the real superpower. But, as they found out, this discovery had a dark side. And this brings us right back to that bizarre quote from the beginning. The researchers uncovered something they called the partial context trap. And it's a subtle but incredibly dangerous problem where giving an agent some information is actually worse than giving it none at all. Let me show you what that looks like in practice. So, imagine the team's memory has 2 key entries. First, an old one that says, we adopted blue-green deployments. Then, a newer one says, we switched to canary deployments. Now, if you only give the agent that latest piece of info, it sees the current policy. And it will confidently tell you, our policy is canary deployments. But it has zero awareness that this was a complete 180 from a previous strategy, which is absolutely critical context for any future decisions. And this just illustrates the danger perfectly. An agent with partial context is harmfully confident. It gives you an answer that seems correct, but it's missing the vital backstory. On the flip side, an agent with no memory at all is honestly ignorant. It just tells you, hey, I don't know, which is a much, much safer and more trustworthy response. Being confidently wrong is way more dangerous. So the team had these incredible results. But then, the plot twist. They started noticing that a bunch of their experienced agents were all scoring around 92% on their internal tests. And they started to wonder, wait a minute, is our memory system really that good, or is our test just way too easy? So in this amazing display of scientific integrity, they decided to test their own test. They ran a diagnostic they called Eval Meta, where they put their experienced, memory-filled agents up against a brand new, totally blank slate agent that had zero institutional memory. And the results were just shocking. The experienced agents scored about 0.92. The brand new agent with no memory whatsoever scored a 0.89. They were nearly identical. This proved it. Their initial test was totally measuring the wrong thing. And here's what they realized. Pretty much any competent AI can complete a basic task. The real value of a memory system isn't just getting a correct answer. It's getting an answer that is grounded in the team's shared history. It's all about what they call institutional coherence. And that's the crucial thing their original test was completely missing. Now, this realization didn't stop them. No way. It sent them right back to the drawing board to design a new hyper-rigorous experiment they called the V1.5 protocol. This was their redemption arc, designed from all the hard lessons they had just learned. Their new research question was much more precise, much sharper. They knew the institutional knowledge was valuable. What they wanted to find out now was, Does the way you deliver that knowledge to the agent actually change how accurately it can retrieve it? Does the delivery mechanism matter? To figure this out, they designed this brilliant five-way experiment. Each arm, as they call it, tests a different delivery method. You've got PMM, their original system, then you've got Stew Plus and Stew, two different flavors of just stuffing information into the prompt. Then UN, which gives the agent the files but doesn't tell it they're there, testing pure discovery. And of course, Base, the control group with no memory at all. By comparing all these, they can isolate exactly what works and why. And I mean, they were meticulous about this. The new protocol fixes 16 specific mistakes from their first paper. For instance, the test questions are now generated automatically from session transcripts, which avoids human bias. They use an automated score with a locked-in rubric. Every single test is run in a completely isolated environment, and they even log the exact AI model version for every single run. They're not leaving anything to chance. To make sure the experiment was totally clean, they had to go to some pretty incredible lengths. The AI development platform they use is designed to be helpful. It automatically injects context and remembers things. To fight this, they built this whole complex external clone system just to ensure their test environments were truly sterile, and that the only information the AI got was what they explicitly gave it. So, with this incredibly rigorous new experiment in place, what are they hoping to find? Well, they're going right back to their most important discovery and putting it under an even more powerful microscope. They've designed two new variants of the partial context trap. Variant A tests what happens when an agent has old, stale info, but the new, correct info is missing. And Variant B tests the exact opposite. The agent has the current answer, but it's missing all the history that led up to it. This is going to let them figure out which is actually more damaging, stale knowledge or missing history. But ultimately, all this painstaking work isn't just about making AI agents remember facts better. It's really about a much, much bigger goal: building AI systems that we can actually genuinely trust. It's about teaching an AI the difference between just spitting out a plausible-sounding answer and providing an answer that is fundamentally grounded in the collective history of decisions and lessons that a team has recorded. One is basically a parlor trick, but the other, that's institutional coherence. And that is the absolute foundation of reliability. And all of this leaves us with a really fascinating question. For these increasingly powerful AI systems, what's truly more important? The facts they've already got memorized, or the ability to reliably find information and ground themselves in a shared source of truth? This research really suggests it's the latter, and honestly, that might just change how we think about building intelligent systems altogether.